terms over to the other side, we get y cubed plus 2y squared minus 49y minus 98 equals 0. Perfect. Step one. Now what? Okay, and how come? Let's think strategically here. What's our strategy on the left side of this equation now? Okay, and why are we factoring? Okay, because our goal is, if we can break the left side into a bunch of factors, then we can apply the zero product property, right? We'll find the zeros of this function, the values of y that make the function on the left side 0. The only way we can find those is by splitting this up into a product of small factors and applying that zero product property. Then the product of all those simple small factors is 0 when each individual factor is 0. Right? So you see the strategy here. There's a method to our madness. Okay, so we got to factor this. Grouping is correct. Okay, so let's just talk grouping for a second. Review some stuff. Is grouping going to work here? Yes. It is. Yeah. How do you know?
Because you can take out y squared and you isolate y on both sides.
Oh yeah. Okay, but if I look at those 4 terms, this is not an essential step, but for this level, for you guys, I think this is something you want to be thinking at kind of a diagnostic level here. Yes, how do we know?
It's because if you take 98 and divide it by 49, it's the same fraction as on the left side, 2 over 1.
There you go. Okay, so if we take the ratio of the first 2 coefficients and the ratio of the second two coefficients, they're equal. Yes?
Plus the exponents.
Exactly. There's the other part. So there's 2 parts of this to our test. There's the ratio test, which says if I take the ratio of the coefficients, they're equal, right? So I get 1 over 2, or 2 over, you can do it either way, it doesn't matter, equals negative 49 over negative 98. Remember, if those are big numbers, just look at the cross product, see if they're equal, and they are. I get negative 98 equals negative 98. And then the other thing that's important is that the variables have to step down by the same amount in each group. From the first to the second part of each group, the exponents are dropping by 1. So those 2 things combined tell us that, yes, grouping definitely is going to work, right? So it makes sense for us to just plow through and proceed. We're going to get into the reason for you guys this is a big deal is because later on in the class at the end of the year, we're going to come back with some much better, more sophisticated tools and look at problems like this and some bigger ones where a lot of times it's not going to work, right? There can be some other things we can do, and it's just quicker not to have to go down that road of going 2 or 3 steps into this process to find out that grouping isn't going to work, right? We can just be more efficient by just kind of previewing and looking ahead here, which you can do in your head. You can look at this and just say, okay, coefficients, check, yeah, okay, that's going to work. And now we can be confident going forward and not wasting time. Okay, good. So now let's group. What do we do from the first group? How do we
Take out y squared.
Okay, good. We take out a y squared, leaving behind y plus 2. Good. Second group, we already know in advance that we're getting y plus 2. This is going to work. And then what has to go there?
Negative 49.
Okay, good. Okay, so one more step and we're done with the grouping part. What do we end up with? How does the left side factor?
You have to take y squared minus 49.
Okay, that's fine. Now, everyone looks at this differently, and that's, you guys, I mean, you're seeing these patterns. For me, the easiest thing to do is to say, okay, I'm going to try to factor something out of these 2 terms. There's the common factors, the blue factor. I'll undistribute that, and then what's left behind if I do that?
Y squared minus 49.
There you go. Okay. Okay. And now we're able to just, now really, later on, we're going to be able to look at this and say, we don't even have to factor this anymore. And this new textbook does things in a slightly different order, and it actually shortens this unit a little bit, which I sort of liked, but we skip some things that we don't do until later. I don't know. I think this is better. jury's still out. We'll see at the end of the year. I kind of like the way it progresses. But we haven't talked about how we could just set this factor equal to 0 and solve. Later on, we will. You guys may know, like we could say y squared minus 49 equals 0, y squared equals 49, so y equals plus or minus 7 by the square root property. We'll review that soon. For now, we're still factoring, right? Just know that there are some other ways to do this. But for us now, how would we break this down using factors? How does y squared minus 49 split apart?
Y plus 7, y minus.
There you go. Y minus 7, y plus 7, and then we've still got our y plus 2 out front. So we get 3 solutions and we're good, right? What would my solutions be? There you go. Okay, good. Make sense? Not so bad, right? Okay, let's look at this guy. Did I do what I wanted to do with that one? Oh, you know what I actually had? I think. Yeah, okay, so if we did this guy right here, the only difference would have been, I wanted to do one that was just a tiny bit harder, but the only difference would have been that we would have had an additional GCF, a constant GCF that we could have pulled out front. Okay, so how would that have changed things?
Yeah, you could just move everything to the left and take out a 4.
Yeah, all I would have done, I would have had, like if I had, gosh, I kind of want to do this. Here, give me one sec. I'm going to do this. I'm going to just copy this. We won't do the whole problem, but I want to just show you one thing here that I think is significant. Yeah, go ahead. Okay, yeah, what about one like that? It's again, this is a grouping problem, right? So we're going to move everything to one side, but I want to mention one other thing here. Okay, what's the first thing we would do here on the left side?
Take out a 4.
Take out a 4, exactly. So when we take out a 4, put the rest in brackets because there's a bunch of other stuff we're going to do. We get our x cubed plus 5x squared minus 16x minus 80, something like that. I hope I did that right. I think I did.
Yes.
So when we split this thing up, we're going to have this 4 out in front of everything, right? Now, if the question said factor this completely, that 4 would have to be left there. Agreed? Because when we factor something completely, we're breaking the original expression. Say we started off with just that stuff. All the stuff that we end up with in factored form, if multiplied, has to give us back what we started. So we need the 4. But if we're solving an equation, are we going to get any solutions from that constant factor? No, because there's no variable there, right? So could we divide both sides by 4 if it's an equation? Sure. We could divide that 4 away because it doesn't contain a variable. So we could just even get rid of that if we want to. We don't have to. We could leave it there, right? When all is said and done, our answer is just going to look like this. We're going to get 4 times some factors with x's in them equals 0. I'm going to get solutions from each of those factors that have x's in them, right? But not from that one. You can leave it there or you can divide it away. Here's kind of a rule. You can divide both sides of an equation by a constant, by a non-variable, anytime you want to. That's fine. We do it all the time, right? You just can't divide both sides of an equation by a variable or you can lose solutions, okay? We'll come back to that again and again. All right. How about something like, oops, that guy. Okay, factor completely. Again, that's probably a little low, right? We can do better than that. What do we do here? What you're thinking?
You just
That's a big number, 2401. But what's the first thing we probably want to see about that number on your graphing, on your scientific calculator? Say it again. Square root it, yeah. What that is? What squared? Anybody know?
You know off the top of your head? It's like 25.
It's like not quite.
It's like 24.
It's like 49.
No.
Okay. So this does work out to be, if you square root that number on the calculator that you have access to on this one. And by the way, on the retake, I rewrote this question. I got into the code and rewrote it so you can't get such a big number on it. But so what if you do? They're all good. Obviously, if this is factorable, that has to be a perfect square, right? In fact, it has to be a perfect fourth, but we'll get there. So we could first of all recognize that this is w to the fourth minus 49 squared. How are we going to factor that? Yeah, w to the fourth is itself a perfect square. W to the fourth is what squared? W squared squared, exactly, right? So this looks like w squared squared minus 49 squared. That's a difference of squares, isn't it? That's a squared minus b squared, right? So we can split this apart into w squared minus 49 times w squared plus 49. Does that make sense?
Yes.
Okay. And are we solving an equation here? No, we're just factoring. Okay. So then can we go any further?
Yeah.
We can't. This guy can't. Can this guy go further?
No.
No. Good. So this one splits apart into what? Good. And because this is a sum of squares, there's no pattern. So that one doesn't. Okay. Good. All right. So far, so good. Okay. How about this one? What would I have to do first here?
Take out
Factor out an x. Good. So I take out my GCF, and then I'm left with what?
18x squared minus 17x minus 1.
Okay, so a lot of times I think on this one, based on the little bit of grading that I did, and I think I'm just going to bunch even grade. I didn't want to grade this one, right? How about if we if you're done with the test, if you really want to finish, that's fine. But otherwise, let's just fold on this one and restart. How about, right? Okay, so it's just too depressing to grade. I don't want to do it. Well, I'm excited for the retake. That'll be more fun to grade. Okay, so if people miss this, they didn't go any further with this one. Okay, is that factorable? And I'll admit here, going forward, solving equations that have trinomials that look like that, we're very seldom going to take time to factor those anymore. We've got better techniques that we'll learn in the near future that'll be better ways to deal with complicated trinomials. But the expectation at this point is you got to be able to factor those. And there is value in being able to factor those. So can we? How do we know? Magic numbers, you betcha. What would the magic numbers have to do?
Multiply to negative 18.
Good. Multiply to the outside product, add to the inside number, right?
It's just a trinomial.
Okay. Now, so you've probably noticed this, and here's something you can file away. Anytime you're looking for magic numbers, when the number they add to is only one away from their product, what number is typically involved in the magic numbers then? One or a negative one, exactly. Yeah, there you go. Right. So here's an example of that. What would my magic numbers be?
18.
Negative 18.
Oh, yeah.
There you go. Negative 18 and 1. Good. So we'll split this guy up, and we end up with an inside maybe brackets. We get 18x squared minus 18x plus x minus 1. We've got our x out front. And now we would just factor that thing by grouping, right? Okay, so we end up with, if I group this, what am I going to get?
18x x minus No, you shouldn't take 6 hours.
There you go. Plus, good, good. And then, so what do I end up with? What goes there? Yeah, it's just, we don't have to write it, but there's a 1 there. And so the final answer is, we've got our x out front, and then we're gonna pull out another x minus 1, right? Times what's left? There you go. Good? I know, it seems like you guys know this stuff. I don't know.
Overthink it in the moment and then do the wrong question.
Okay, okay. All right, first step here, if I'm solving an equation, what do I do? Good. Standard form. Okay, again, I mean, like this, you're gonna tell me how to do this and it's gonna take like 20 seconds. I don't know. So what do we do now? Factor out a y, leaving behind. And then how's that factor?
I probably.
No, that says 54%.
So what are my solutions on this then?
0, 10.
There you go, 0, 10, negative 10, right.
That's probably why.
Oh, is that it?
Yeah.
Okay, right, okay, so you get the 0, right? There's 3 factors there that have variables.
Wait, that's where the 0.
I like looked at the answer and I was like, where does it
Sometimes I should just remember to just put a 0 in on that.
I just like forget to put the 0 in.
Wait, you're supposed to have a 0?
Okay, so let's make sure you guys understand why it's there, right? So by the 0 product property, the product of these 3 factors is 0 when the value of each factor is 0, right? So just ask yourself, what value of y makes that factor 0? Negative 10. That one, 10. That one, 0. Anytime you have a monomial factor with a variable in it and you're applying the 0 product property, what's your solution? 0. Yeah, every time. Okay. I mean, I don't know. Do we? Okay, so I tell you what. This one I kind of get a little bit why people might have. I can get why there might have been a little bit of consternation on this one. Let's go through it. And I think I'm actually on the retake. I might take this one off just because we're going to come back and revisit this later and ask much more interesting questions about it. And we'll see it enough then that maybe we don't need to spend time on it now. But I still want to go through it because the factoring part's important. Because the factoring, like, if there was a part that you maybe missed on the flashcards, it was the part that involved the cubes, right? Like the sum and difference of cube stuff. I just don't think you guys memorized the formulas on that. Because people were proceeding like they were thinking about it right, but they just hadn't made flashcards. I don't know. Make those flashcards. So obviously we set this equal to 0 first, right? Okay, what do we do first? Take out an x, good. That leaves us with x cubed minus 8. Okay, so now here's the part where I think people messed up. How does this break apart?
X minus 2 x squared plus 2x squared plus 4.
Okay, that's right. Okay, how come? Because the pattern is the a cubed minus b cubed, it factors into a minus b, right? Whatever the sign is there, goes there, and then it's going to flip, and then it's always plus there, right? Remember we talked about that pattern? Okay, so it works the same way for difference of cubes or sum of cubes. Same opposite plus every time in those patterns, okay? And that's just an A and a B, A squared, AB, B squared, right? Okay, when this is equal to 0, when I go to find the solutions of this, the reason this is more interesting maybe later than it is now, when we're looking for the solutions, what's the value of x that makes that factor 0?
0.
How about that one?
Positive
How about that one?
2.
Arnie, right? Remember, yeah, that's the one. Remember we said about that. That's the irreducible quadratic. It's never going to factor, and it's never going to give you real zeros. Okay? It's going to give you, and the reason we'll come back to this, and I don't mind taking this off now, is because later on when we start talking about imaginary numbers, this is going to give you a complex conjugate pair of complex solutions, which involve imaginary numbers. Okay, right now, so we're missing so much of this right now. We don't get to talk about that stuff, but later we do. So I will just put this stuff, we'll put that one away. I'll take it off the test for now, because we're going to come back later and deal with it in more detail, and it's much more interesting later. So that one's gone, but we'd only get 2 real solutions from this, right? Okay. Okay, let's talk about this one. Okay, again, this is like, and I also get why these are normally, it is completely normal for the word problems to be lower. That's expected. Let's try to get past that, because I promise you that word problems in math classes are always easier. The math is always way easier. It's just getting to the math is the only part that's tricky. Okay, so how do we set this up? We draw a picture, right? How am I going to label the dimensions of this if the length is 5 less than twice the width? Okay, so if we call the width x out here, okay, that's fine. What's the length then?
2x.
And the area is 88. So what's my equation?
X times 2x.
There you go. Now we can just flip into math mode, and that's not a very tough equation to solve, right? Well, what would I do to solve that thing? What do I do first? Distribute. Good. What do I do with the 88? Subtract it. Good. Okay, good. And we've got a quadratic equation. Later on, we wouldn't bother trying to factor that. We would just apply the quadratic formula. In this case, we wouldn't even complete the square. And for reasons we'll talk about later, we would just use quadratic formula. But for now, we have to factor that. So we got to find, let's practice this again. What do my magic numbers have to add to or multiply to?
176.
That's it, negative 176. And they have to add to what? Okay, those numbers might be hard to find, so making a table here is of some use. Making this table, I can just imagine if I were in your position, I think, God, do I really have to make that darn table? By the time you write it down, you're almost done, right? It's just get used to, even just getting used to like writing, making the table makes it easier to do. Once you do it a couple times, it's no big deal. So we need numbers, signs of the two numbers that multiply to this negative or what? Good. The bigger one's negative, smaller one's positive. Because they multiply to a negative, are we going to scrutinize pairs of numbers that multiply to negative 176 or pairs of numbers that add to negative 5? Add to negative 5. Good. So we could start off with something like negative 14 and 9, and it's way too small. I get negative 126. I got to get bigger. What would be a good choice? There you go. You already have it. Negative 16, positive 11 is negative 176. There's our magic numbers. We split this thing into negative, what did we say, 16? Okay, and then from there on out, I mean, we probably don't even have to do this, right? I mean, then we just factor that thing by grouping. Do you want to anybody want to finish this?
Yeah.
Okay, you want what? Yes? Zip through it. Okay, we can do it quick. Let's just go through it. So here's our first group. There's our second group. What do we factor out of the first group?
2x.
Okay, what's left behind? 8, there you go. So we know it's gonna work. So we got an x minus 8 there, what goes there?
11.
There you go, plus 11. It all equals 0, so what are my factors?
2x minus
X minus 8, go ahead, times
2x plus 11.
Okay, so my zeros. X equals 8. X equals, I guess we'll do it in blue. X equals. Okay, those are my mathematical solutions. Are any of those nonsensical in this context? The negative one makes no sense as a side length of a rectangle, right? So we can immediately discard this one because it doesn't apply to our application. If 8 is the width, how would I calculate the length? Plug it in, right? And I got the dimensions. Okay, good? All right. Okay, so, this one too. So then we already talked about this stuff. We don't need to review the test. Factoring this, people tried to do more than they could on this one, I think, right? People tried to go further. There's not a lot you can do. If I'm gonna factor this, really, what's the only thing I can accomplish?
Take out an X.
I can take out an X. And I'm left behind with, oh, S, sorry.
It's the same thing.
No, it's not.
I was like, I can't. Both of those wrong.
Okay, here's the other thing. Some people did. So if I factor out an S, they left it like that. Well, that's not quite right. Good, I need a plus 1. Okay, here's a way to a concept you want to attach this to. If I'm factoring something out of a 4-term expression, how many terms have to be left over? 4, right? Because factoring means I'm dividing, I'm not subtracting. There's no way I could ever end up with fewer terms than I started with, right? And if I want to know how I get there, remember, all I'm doing is I'm dividing each of these by S to see what's left over, right? Okay. Now, once I get here, can I go further? At this point, we have no recourse for a 4-term polynomial except for factoring by grouping. If factoring by grouping works, that's it. We cannot break it down any further. And grouping can't work here, can it? Look at the coefficient test. 1 over negative 1 is not 1 over 1, right? And even if you forgot that stuff and you started factoring by grouping, you would find that it would break down. You could not get the same leftover factor in group 2 that you could in group 1. It's impossible, right? It just wouldn't work, and so you'd have to erase those steps and go back. That's the answer, okay?